Let me begin by saying that thread locals have been in the Java ecosystem since the 1990s, and it remains a valid way to set and access data within a thread. But we should also be aware of the downsides of using thread locals. In this lecture, we will see some of the problems. The first problem with thread locals is that it has unconstrained mutability. By mutability, I mean the ability to change the thread local. Set method on the thread local can be called anywhere in the thread, and get method can also be called anywhere in the thread. That is, anywhere there is visibility of that thread local. Remember, by mutability, I mean the mutability of the thread local and not the mutability of the value set for that thread local. They are two different things. To clarify this point, if you look at one of the earlier diagrams on the right, the thread local for user can be changed by using the set method right here. This is the mutation we are referring to. This is independent of the change to the user object itself, which is here. I can set the ID for the user, which is basically mutating the user object itself. That is not the mutation that we are referring to. So basically, even though Java allows you to set thread locals from anywhere in the thread, a good practice to design it is to be able to set at only a single location and then use it at more than one place. That's a pragmatic approach, and that's what we have seen more than 90% of the time developers do. Also, if you don't need the value to be mutable, then you can simply use a Java record, which is by definition immutable. So in this example, user could be a Java record instead of a Java class. The second problem with thread locals is the unbounded lifetime of the thread local variable. Thread locals remain in the thread local map until the thread dies or until it is removed explicitly using the remove method. We have seen this before. So if the developer sets the thread local variable but forgets to remove it, then we have a potential memory leak in our hands. This is not a problem with virtual threads as much. Because virtual threads are supposed to be used and discarded, they are never pooled. If you find yourself trying to pool virtual threads, then you are doing something terribly wrong. In other words, virtual threads make the case for thread locals actually stronger because it doesn't have the memory problems which it has in platform threads. So let's say you're using a thread pool, obviously with the platform threads. If you look at an individual thread inside the pool, it's running different tasks continuously. You see in the diagram task 1 and task 2 submitted by other threads. Task 1 sets a thread local right over here. What happens when the developer forgets to call remove at the end of the task 1? The thread local value would not be garbage collected because the reference to that is still in the thread local map for that thread. And the thread is not going to die anytime soon. The entry in the thread local map will also not be removed. Worse still, the thread will start running some other task soon, which now has access to the thread local created from task 1. Now this scenario could create some very hard to debug problems and possibly some security issues too. As developers, we should be always removing the thread locals from the map, possibly in the finally block. The next problem is really to do with inheritance of thread locals. Basically, the inheritable thread local objects. We already mentioned that when a child thread is created, the inheritable thread local map is copied over to the child. The reason the JVM needs to do this is that the child should be able to set its own value. This is a reasonable implementation given the constraints. But consider what happens if we are using a lot of virtual threads. A developer can create tens of thousands of virtual threads in the JVM. In structured concurrency, we can create these child threads, and these child threads can in turn spawn other child threads. If we copy the map as we do for all of these threads, we have a potential memory problem in our hands. Also, there is a performance problem because of the copying of these maps. Considering all of the issues that we talked about, the Java engineers have come up with a solution to this problem. A new class has been introduced called scoped value. If you like this video, support this channel by giving a thumbs up. And don't forget to subscribe to this channel for more quality content.